This FRQ is a rate, I like to call these FRQs rate in, rate out. So, think about that if you got a rate in, rate out. So when you're thinking about rate in, rate out, think about, okay, well, I'm on that second step of my stairs. Here's where the rate is. This is the rate of the rate. And this would be the amount. So you can kind of see, well, what happens as you build this? So we're given here that the rate in this whole problem, G of t is the rate in. And if you look at it, it's tons per hour. So that's an important piece. Now you're at that middle step, and that's going to be measured from 0 to 8 for t. And then if you look at the next thing, it says that the grant processes at 50 tons. Okay, so it begins to process at the beginning of the plant. Oh, there are 50 tons of unprocessed gravel. So when t equals 0, there are 500 tons of unprocessed gravel. And it says during operation from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So the 100 tons per hour is the rate out. So we got a rate in, we got a rate out, and that's also going from 0 to 8. It's important to kind of note where they're working from. So if you think about what's happening on this, is you got this rate in, rate out, and then you start answering questions on this. So then it says, okay, what is G of 5? I didn't know I had some other things here, so let me clear this page, and then I can start to work with it. So the question is, in part A, is what is G prime of 5? That's going to be a calculator question. This is a calculator exam part, and you're going to know that it's a calculator one because you would have a difficult time integrating or differentiating this by hand and then coming up with the answer. So just know you can use a calculator. I'll try to put that note on there. So when you find this, you're going to do this on the calculator. So on the calculator, and that's going, you're in hit menu, and then you're going to go to calculus, and then number 1 is numerical derivative at a point. And if you get this, you'll end up with negative 24.588. Now, right away it says using correct units, interpret this. So write the units on there. If G of t is in tons per hour, then this is going to be in tons per hour, or tons per hour squared. And then what you kind of think about is, okay, so we got a negative. We got G prime is negative. If G prime is negative, that means gravel, the rate at which gravel is being processed, because that's what G of t is. G of t, the rate at which gravel is processed, is decreasing by 24.588 tons per hour squared at t equals 5. So because it's negative, you got to think, okay, negative goes with decreasing. Remember the chart. And then that's how you would end up with that. Now it says find the total amount of unprocessed gravel. Again, in this step thing, this is where G of t is. G of t is right here. So if we need to find out the amount, like we are in part B, of unprocessed gravel that arrives during the hours of operation, which is 0 to 8, then what we're going to do for part B is we're going to integrate from 0 to 8 of G of t dt. And you want to write that down. You want to do that on the calculator, and you'll get 825.551 tons. But if you only leave the answer, you will not get credit for it. You get credit for writing the integral and then writing the answer. Anytime you do an integral on your calculator, you have to write it down on the paper. Now, part C. Part C says, okay, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? Okay, well, if the amount is increasing, the rate in minus the rate out needs to be positive. If the amount is decreasing, then the rate in minus the rate out would need to be negative. Because remember, negative goes with decreasing, positive goes with increasing. So what we want to do is we want to figure out, well, what's G of 5 minus 100? If we find out G of 5 minus 100, which is like 98.140764 minus 100, since that is less than 0, we know the amount of gravel is decreasing at t equals 5. And that information up there is going to give it to you. The work over here that you showed is going to give it to you. So then the last part, and I guess I got another page here. Let me cancel this page out, clear that one out. The last part, part D. Part D is saying, what is the maximum? So they're looking for an absolute maximum. That's what we're looking for, an absolute maximum, because it says what is the maximum. So we know it's the absolute maximum during the hours of operation. Well, we know that the hours of operation, we're looking for a maximum amount of gravel at the plant. We know that we got T here, and we have an equation, 500 plus the integral from 0 to T of, or 0 to X will make it, 0 to X. I don't know if do they use S or what do they use up here? Yeah, we'll make it 0 to X of G of T minus 100 dt. That's our equation, rate in minus rate out, the integral of the rate in minus the rate out. Now we can do all of this work. Now, one of the things that we know is at 0, we have 500. That's what it started with. At 8, we could do this integral, 500 plus the integral from 0 to 8 of G of T minus 100 dt. And we could do that right on our calculator. You'll end up with 525.551,089, something like that. Now, you got to figure out, well, when is the processing, when do we get a critical number? So a critical number on these problems is when the rate in is equal to the rate out. So what we can do is we can figure out, well, when is g of t equal to 100? Or when is g of t minus 100 equal to 0? They're the same thing. You'll figure out that you doing that on your calculator, you get 4.292348 and you need to report things to 3 or more decimal places. If you use it in a calculation, you want to use more than 3 decimal places. I would suggest using 8 or 6. And you can report more than 3, and it never hurts you to report more than 3. And then you would just do 500 plus the integral from 0 to 4.923480 of g of t minus 100 dt. And what you'll come up with is 635.37123. And so so from this chart, here's our maximum right here. There's our maximum amount of gravel. That's where we get the maximum. So we just say maximum amount of gravel is 635.376 tons. And then that's the answer. Not a bad question. I know it took a little while to explain it, but not a bad question. If you don't understand something, let me know, and I'll see if I can help you.